Okay, so today we are starting a new, very ambitious project. I've been experimenting with some smartwatch designs. I do one of these for one of the classes that I teach. The previous version was just a simple LED watch using various neopixels. I designed one earlier this summer that uses a Atmega 328 with a 0.96 inch OLED, and the issue I'm running into with that is just you can't get Atmega 328s. So the one thing that you seem to be able to get your hands on these days is an ESP32. So I'm going to look at designing an ESP32 watch today. There's going to be a lot of different systems that I need to get in order to make all of that work. And so we're thinking about, I've got myself a little to-do list over here. So yeah, so everything from power, so it needs to have the charging module on it with a battery. I'm going to use an actual rechargeable lithium ion CR2032 battery. It's going to include overcharge and discharge protection. You'll be able to charge it up over a USB port. That I'm also going to try to use to be able to do some programming for the ESP32 because we're going to be using the bare modules to keep the footprint small. ESP32 is going to have all the programming circuitry, the reset and the boot buttons, as well as 3 digital buttons that will be able to kind of control various functions and features on the smartwatch. Also going to include an accelerometer. I'm not using a popular IC for the accelerometer because they're, again, hard to get your hands on or really expensive. And so I'm using one of the less expensive ones that I've found on LCSC and have been doing some experimenting with. I built a little development board just to kind of get my feet wet with it, and it seems to be working fine. And the last thing we're going to be using is one of these GC9A01 LCDs. It's a round LCD, which I thought would be kind of an interesting thing to design for. And then last, I'm trying to kind of build this all in a very small footprint, so trying to keep it smartwatch sized. So my goal is to something around 40 by 40 millimeters, kind of keeping in line with kind of Apple's smartwatch. Thickness is going to be a concern, so we'll try to do that and try to just really design a compact circuit. And I'm going to try something I've never done before, which is a 4-layer board. And so hopefully that will buy me some additional leeway with respect to being able to run all the traces for this. And so you can see I've got tons of tabs open here because I've got lots of resources that I'm going to be pulling from today to try to make this all work. So probably easily the most complicated project I've ever designed. So let's get into it. Don't know how long this is going to take. I don't know if I'll have to do this in multiple parts, but we're going to give it a shot. So we'll call this smartwatch. And since this is technically the third one, like I said, the first one was just an LED watch. Second one was an OLED with an Atmega 328. This one is very different, but we'll call this one version 3. So we'll start a new project. I'm going to be pulling from some previous circuits that I've designed, a couple that I've done on this stream. Smartwatch V3. And so if I'm kind of glossing over some of those, you can kind of check out some of the other resources that I have designed. And so the first thing I want to start with is actually just power. If I kind of just double check my little thing, yeah. And so I want to look at CR2032 battery holders. And so I'm going to kind of go shopping for those. It used to be that LCSC only had like 2 of these battery holders, but now they actually have a really decent selection. A couple things that are going to be really important for me is first and foremost just low profile. So because we are kind of doing this stack design where I'm going to have this kind of like layer of components, then the PCB, then the battery, then the screen is kind of going to go on top of that. The screen attaches with a ribbon cable, and so it's going to kind of like wrap around onto the top. So it's kind of a thick design, so I'm trying to keep it as low profile as possible. And then also, because of how densely I anticipate everything's going to be packed, I'm probably going to be looking for surface mount designs. Definitely want things that are in stock. So we're going to kind of take a look around. There are some of these that I've used before. and some that I haven't. And so they've got these like small little stamped ones, which are probably fine. I'd love to go towards something more robust. I'm gonna sort by price here. But ultimately, it's just going to come down to what's going to hold the battery in there really well, and what's going to work. So trying to keep an eye out for these kind of stock numbers, because I just hate buying things that just, as soon as you get them and you start incorporating into them and you want to continue using them, then they just like absolutely run out of stock. I don't like these ones as much, and so that's just because they they don't have a stop on them to kind of keep the battery from slipping out. These big plastic ones are okay, but they're generally very, very tall. So we're gonna open that one up and look at it to see kind of how tall it is. But yeah, I'm really looking to not add a lot of bulk. These are all really big. Okay, so let's look at this plastic one. So I've seen these used before. Let's look to see if we can look at some stats on it. Yeah, so 5 millimeters. So I've got my little calipers out here. Yeah, that is really a little bit more than I'd like to dedicate to it. I'm going to grab a circuit real quick and just measure kind of what my current system uses. That took me longer than I figured it would, but so this is kind of the existing module that I use. It's just this little metal stamp version, but I like it because it's got a stop that holds down the battery. Let's look at to see kind of how. So like I said, this one's 5.5 millimeters tall. So I'll dial that in on the calipers and we'll see how this one compares, because maybe it's, oh yeah. So it is taller, because this design is about 3.5. So let's look at that. And so we come over here. I'm gonna just look real quick. So CR2032. And so I've got a couple of these that I've worked with before. I don't like that one. Don't like those. They are the. Don't like the through hole ones, because like I said, the through hole is gonna just be a pain. Do these have a part number associated with it? They do not. Well, that's frustrating. I don't know what that part is, despite the fact that I've ordered those a million times before. Well, I guess let's look. So I didn't see that in this list, so it's possible they don't sell it anymore. Oh, this one has a stop on it. 960 in stock. Is that enough? This one has a stop in it, 785. That's just worse. Some of these are just so kind of rinky-dink. I'm concerned about throwing them on a project like this. It really needed to be robust and not kind of jiggle out. Alright, we're going to try this one. It's got a big C number, so let's have a look-see. I knew this was going to be the, the part that I didn't have as figured out. Let's take a look there. So, yeah, 10 minutes in and I got my first component placed. We're making great progress. Okay, so I got my battery. Now we're going to look at the LiPo charging part of this. And so for this, I'll actually be able to use the 3.3 volt charging setup that I developed in one of my last ones. And so we've got kind of, I'm going to make some modifications to it because I don't really need as many of these connecting ports since everything's just going to be on power or on board. But I'm going to go ahead and kind of copy this whole thing over. I do want to make sure that I used the right USB connector for this one. So that is the 4-post one, so that's good. Okay, I like that one. And so, yeah, let's grab this whole thing here. Ooh, I did not mean to grab. There we go. Okay. And we're going to drop this right here. And we're going to kind of sneak some things together just to make sure it works. Okay, so yeah, so on my old one, like I had this whole thing where you could like, you know, attach other things going in. We don't need that. That's going to be just, you know, incoming power from the USB. Yeah, I also remember that, you know, we had this whole like V out and this whole battery thing. So we're going to take a look at that because that seemed to be a little bit superfluous, especially since I don't need, again, this you know, these male header pins because it's all just going to be on board. So protection is going to come over here. Here's our 3.3 volt, and again, I'm going to be very kind of thoughtful about, you know, what these headers look like. You know, because again, like, don't really need that as a header pin, because again, we'll just connect into a 3v3 line. So I got to keep that in mind. We got a V in. Right, I don't think I'm using any VCCs in here, and so I think I'm going to replace these 3v3 lines with VCCs. That way, for the rest of my circuit, I'll just be able to refer to it as VCC. And so, yeah, I'm going to keep my battery here. Like I said, lots of circuitry here. And one of the dangerous things about kind of copying and pasting is if you made a mistake, you're going to bring all of that with you. So I'm just going to really take a close look at this. And yeah, want to make sure that everything's good. So I think I'm going to replace these V outs with bats to kind of be representative of my battery. And so I'm going to go ahead and try to find all instances of that. Again, just because I think in my original design, battery and V out ended up being the exact same thing. And so that kind of made the circuit a little bit easier, but also kind of confusing here. So I'm going to delete that and then just bring that guy up there and make sure that it is in fact connected. So there's that. Okay. Yeah, so there's, again, there's a V out, there's a V out. So let's go ahead and change that over to bat. Let's change this over to bat. And so, you know, the voltage will come out of the battery and into this 3.3 volt converter that we designed last time. Do I see any other V outs? Where did I get them all? So let's double check here. We are going to be kind of using these 3 pins for programming. So we'll come back to this. Like I said, we're going to kind of, in addition to this, we're going to build a special board that interfaces with like an FTDI programmer so we can actually program these bare chips since they don't have the serial chips on them or the USB chips on them. Let's see, so VN, charge, standby. Yeah, I'm going to have to think whether or not I have room for these charging and standby LEDs. Again, those are nice to haves, but they may not be everything that I need them to be. One other thing we're going to look at, I need to kind of put on my list, is we need to include circuitry for battery monitoring. So that we can kind of incorporate that into our design where it'll be able to read the voltage on the battery and kind of show that on the watch. Because I think that'd be cool. If we can get that working, that may replace the need for having the charging and standby LEDs, because then you can just open up the watch and see that it's charging, which would be a kind of a cool feature. Okay, so that all looks well and good, albeit it looks like we got a lot of stuff going on. I'm going to try to organize this just a little better because I've got a whole lot of other stuff that's going to be coming on screen. So we may very well end up having to expand this this board. Kind of scoop that up. Yeah. Move these guys in just a hair. Don't want to crowd things too much. Still want it to be visible, but like I said, we got a lot more that's coming on here. Okay, and then I'm just going to take a big old square and kind of cordon that off so it doesn't spill over into other things. So that's kind of power. Yeah. Ooh, looking over here, I do see some stuff. Again, this is like header pins, and so I will not need header pins because again, we're just going to use those that 3v3 flag. And I did say I wanted to change those over to just the VCC pins, so I'm going to go ahead and do that now, just so that lets me kind of keep that in check. Okay, so there's a 3v3, there's a 3v3. Like I said, just old habits die hard, so I'd rather just use VCC pins to keep things nice and simple. So that should be all of them. Okay, so now I know, just in my head, I'm making a mental note that VCC is, in fact, a 3.3 volt line. Okay. Just try to do a little bit of management on all that stuff. Okay. Alright, so that should take care of my power. So I'm just going to do a little checklist. So I do have my battery right there. I've got charging, which is this module here. I've got my overcharge and discharge protection. I've got my 3-volt changeover. Yeah, and I'm using the right USB module. Sometimes I screw up and use one that only has 2 anchor posts, and those are not very strong. They tear out. I've unfortunately torn out several before, so I have to be careful about that. Okay, so now let's look at the ESP32 module. And so I should have one of those around here somewhere. There we go. So I'm using this the ESP32 32D, and these modules are actually really tiny. I've got one hanging out right here. So compared to the development boards, which I mean aren't super big as it is. So here's kind of the development board that you can kind of see, and then here is the accompanying chip. And so yeah, there's actually a pretty decent difference in terms of size. And so again, just kind of one of the constraints of designing for wearables is designing as small as possible. So that's why, like, even for like the accelerometer, I can't use like an off-the-shelf accelerometer because they're all already soldered to PCBs, and that's just taken up oodles of space on a board that I don't have. Okay, so we're going to use this ESP32, and again, we'll have to kind of build some of our own circuitry around it so that we can program it and interface with it. But here it is in all of its glory. And we'll kind of just get those in order there, please. Okay. So we're going to start off just, I always like to do my power and grounds so I don't forget. I have literally had a board come back and I completely neglected to do any kind of power or grounding on it, and that makes for some ugly jumpers soldered onto your board. So I'm always conflicted about this. I know you could just connect these two grounds together and that'd be fine, but at the same time, I get superstitious about missing that kind of thing. So I know it maybe looks a little bit weird, but I always just put grounds on all of them instead of trying to net them all together. So I do want to just double check to make sure I get everything kind of where it needs to be. So I've got the documentation pulled up for this, and so I do see that 3 volts is the power supply. So that's on pin number 2. So let's go and grab that VCC that we know is a 3-volt line, and we'll get that plugged in here. And actually, one of the benefits of using VCC as a 3.3 is all the I2C stuff. All the sensors I'm using are 3-volt rated. The screen is 3.3 volt rated. So again, it's just from here on out I can just use VCC, and that will be nice. Okay, so I think I've got everything in terms of getting that powered up. And so I do want to start looking at what it takes to actually program this thing. So let me kill a couple of these extra tabs that I don't need. Cool. Okay, so this is an example that I found that uses, again, similar module to me. And so it's got the reset pin, the boot pin, and then again you can see it getting hooked up to this kind of this programmer that uses 3 pins. And I think, like I said, it just uses an RX, a TX line, and then a 3-volt connection. And so I think I can make this work just through the values that I have here. So we're going to try that. So we're going to start off with a net flag here. Yeah, probably. Well, yeah, that's fine. I'm trying to decide if I want an extra ground there or not. You know what? I'm going to. Just for funsies. Okay, and so I'm going to have this be TX and this be RX for transmit and receive. Okay, and then one of the things you always got to keep in mind is, again, the TX of the UART is going to be the RX of this. And so in my mind, I kind of have to be thoughtful that when I design my little module that's going to connect to this programmer, that I reverse those. But I will kind of be true to this TX is going to refer to the TX of the ESP32. Sometimes you can get yourself kind of caught up in reverse land and kind of get things mixed up. So it's tricky, but I will try to be smart. Okay, so I can see this TXDO here on pin 35, and that does seem to square up with what I'm seeing on the schematic here. So that's always nice when your footprints and your schematics agree with your data sheets. So we've got those 2 dialed in. Just make sure that there's nothing wonky that's going on. Cool. Okay. And these are grounded. Now again, I gotta be careful. I'm not gonna use the VIN from this one. That's gonna be powering it, but I do have the 3-volt coming through. So that should, to some extent, take care of itself for this part of the circuit. But we do need to have our reset button. And for the reset button, I'm gonna use, I grabbed some, oh yeah, here we go. So I've got these really super tiny push buttons. I really like them. They're surface mount, they're low profile. They solder really nicely in the reflow oven. So let me so I can get one kind of up nice and close there. And so, yeah, they look pretty good. And they've got a little bit of travel on them, so they should be okay for kind of doing this kind of, when you program it, you got to kind of hold them down to do stuff. And so I'm actually going to just double check to make sure that they still stock them. But it is C10852. I always like to make sure these things are still obtainable. Now what's interesting is the mounting type. This took me forever to find them because the mounting is like, I would have thought like surface mount or something like that. They call this brick nogging, and I honestly don't know what that means. It sounds really cool though, but yeah, I couldn't find them for a while because I kept looking at surface mount, and that's not what these are called. They're called brick nogging. So there you go. They've got 9,400 in stock. That seems to be fine these days, so we'll go ahead and include them in our design. And I will need 2, so one for the reset, one for the boot flash. And so I'm going to go ahead and throw these in here. Ooh, look at that extended part. Ew, I hate that footprint though, or that schematic. That is pretty ugly. But whatever. Okay. And so, yeah, so we've got, make sure I follow this, this diagram precisely. Let me do that reset pin first. Okay, so it looks like one side of the pin is just going to go to ground. Okay, which is fine. So we'll actually do this one here as part of ground. Okay, and then the other side goes off, okay, through a 10K. And then let's go ahead and look at a 10K. Have I used a 10K before? I thought I had. Let's have a look-see, because I'd rather just use one that I've pulled off of here before, but maybe I have not used a 10K with any of these. Oh, you know what? I could just look at my bill of materials. So, nope, I've not used a 10K, so let's go shopping for a 10K. I should have like 400 of these at my disposal because I use them all the time, but it's always a good chance to kind of check on current supplies. So we're going to look at resistors. I have good luck with 0603s, so that's what we're going to shop for. Let's go find a 10K. There we go. We want them in stock, and let's apply. Okay, sort by price. Ooh, a bajillion in stock. I like these Uniroyals. They kind of match the other ones that I've used. It seems like they have 1.8 million in stock, so they may not be running out anytime soon, hopefully. And so, yeah, so we'll go ahead and use that. I always do that. There we go, 10K. Okay, so there we are. And so kind of go back to our little setup. We know that that needs to go there, goes through the resistor to our 3V3 line, which again is VCC, which is good. Okay, and then I'm going to kind of flatten out this profile just a little bit. The other side needs to go to the enable pin. So we'll create a net flag for that. Call it EN. And with any luck, it's right under 3v3, which again is good. Our schematic is a green. And that's good. Just go ahead and save up there. Okay. Now, what we're going to do is we are going to install the boot flash button. So it looks like that goes just to ground to this D0 pin. And I want to make sure I choose the right one here. I think I actually don't know which one of these it is, so we're going to have to do some digging. So similarly, we'll come over here, we'll ground this side we're going to create a net flag over here. Oh, I did that. Let me make sure I like that I did that. So make sure that's just on the same side as the 10K as the enable. Okay, and the opposite side of VCC. Catches me off guard. I actually usually don't like wiring things up like that because it's ambiguous. Okay, but it's fine. So yeah, so let's look at this. Because I want to make sure that I get in the right one. So we're gonna scroll through and see if these have an included. Kind of. Yeah, let's look at our so we are looking for, just to remind myself, so pin 25, okay, which is supposed to be this, which it does look like that's IO 0, but let's just square that up against everything else that we know. So pin number 25 is IO 0, which is GPIO 0. Cool. Okay, so that does sound correct. So pin 25, IO 0, connect it up. Okay. Looks like they've got this little like status LED in here. I'm gonna leave that off because I've got like way too many LEDs as it is on this thing. So, and I think it's just gonna start getting burdensome. So we're gonna move these guys here, kind of get them up out of the way. Again, just gotta make room for all the other stuff that is gonna be coming down the line for this circuit. Okay, let's save that up. And let's check our list. How are we doing? Okay, so power is good. Programming circuitry. So we got our resistors, USB, boot, reboot buttons, good. I do want to include 3 digital buttons so that you actually have like physical buttons to interact with this. So that's going to be pretty straightforward. I do want to make sure that I am choosing GPIO pins that are actually valid. I had a little bit of an issue with a different circuit board that I built where I just assumed that any GPIO pin would be good, and that is not the case. So for this, I've got these little 90-degree buttons that I would like to try out. So we're going to do 3 of them. Wow, those look weird. Hopefully those are okay. So we do know that they're going to need kind of 10K resistors. So I know that looks weird. I've like legitimately never hooked these up before, so if this looks weird, I apologize. So you kind of get into a habit of like when you have certain parts, like you just kind of have a way of always hooking them up. When you get new parts, you kind of have to figure out like, you know, this balance between the geometry of like what makes sense and then also just logic. And one of the most important things about just designing circuits is just designing so that you can easily catch mistakes because it's easy to make mistakes. Okay, and so yeah, so we'll do power on pin 1. It looks like these are just grounded, or these are just pins to kind of anchor it in, so we won't actually ground them there. Made that mistake one time. Let me grab that out so it's not right on top of that. And then we know that these will ultimately come down to ground. And yeah, we're going to kind of space these out just a little bit more. Do this first. We'll call this like B3 or button 3. And we're going to whatever. We'll bring that resistor with us. Still need a little bit more room. Again, there's probably a better way that I could have been organizing these. What? We're learning. B1. Okay. Don't like that. Yeah, that'll be fine. Okay. So we need to kind of on here figure out what are the buttons that are going to be good to use. What's interesting is I don't know if there's actually a really good way to figure that out. So we're just going to say ESP32. ESP32 buttons. Let's see if I can find any circuits that commonly use buttons and which ones they use. Maybe this actually isn't the best idea because I know I'm going to be using a lot of pins for I2C and for the screen. So I'm going to double check the ones that I need to use for that first. So let's make a little list. So I know I need I2C. I need 3C, dear heavens. I think it's SPI that we're going to be using for the screen. And then I know I need an analog for the battery monitoring. And then I need 3 digital inputs. Okay, so I2C should be pretty easy to figure out real quick. I2C. Using the right variant here. Let's just look. Okay, so GPIO 22 and 21 is SDA or SCL and SDA. Okay, so we're going to square that up against here. So GPIO, let's see. 21 and 22. Okay, so GPIO 21, 22, which again is not pin number 21, 22. Let's see about GPIO 22. Okay, so that looks to be pin 36. Is 22. Okay, what about 21? Okay, pin 33. Let's have a look-see. So that says IO 21, okay, which makes sense. And so IO 21, according to random internet person, IO 21 is SDA. So let's go ahead and flag that up. I really hate how that's placing those. So SDA. Just so we can kind of get that reserved. Okay, SCL is 22. So again, let's look over here. SCL is 22, which is 36. Oh, I see it right there. Good. Okay. And we'll go and get that labeled up as SCL. Whew, okie dokie. Next, we're going to look at what we need for the screen, because again, I know that it's going to need a fair bit. Let's go over here. Okay. And I'm going to go ahead and grab this screen just so we can net flag it, because it doesn't need a whole bunch of stuff, and that's going to just allow us to step through it kind of logically. So I know I'm kind of going off script here a little bit from what I was planning, but I think that's going to be the best way forward. So if I I was playing around with footprints for this earlier. And so let's take a look at this on Easy EDA. Like I said, there's a couple, several people have done these. There's no official thing for it. So I don't like that one, don't like that one, definitely don't like that one. No, 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 nope. I don't think so. Maybe it was one of these first ones. Ah, no, it was this one. I like this one. Okay. Boy, I'm going to find a place to kind of shove this thing. Maybe it'll fit right here. Really going to have to check this footprint against what I know about it. That just looks wonky. Let's grab this down here. I hate that orientation. Yeah, this is probably a bit better. Okay. Alright. Going against what I said earlier, I am legitimately just connecting all those grounds together. Okay, VDD should be VCC. Let's see, in here we've got... I don't like this. So I've got DC, CS, SCK, SDI, LEDK, LEDA, and reset. I've got... Let's see if this sounds... So 1, 5, 6, and 12. Okay, so that is correct. Okay. LED anode, LED cathode. Interesting. We're going to use process of elimination with that, because I am really not sure what to do with that. Okay, so let's take out the ones that we know. Okay, so VCC and ground, check. So data in, and this is where he says that the SDA is the data in, which I assume is probably this SDI. So we're going to call that DN. Okay. The SCK should be the clock, I would assume. SCK. Or actually, no, not SCK. We're going to call it the CLK for clock. We're kind of going with this. Okay, we do have the chip select. That's very well labeled. Let's see this. DC is data command, so that's well labeled. Cool. Okay. Reset. Okay, we'll call that RST. I'm going to make sure I didn't use that elsewhere, otherwise I'm going to have issues. Enable, pin, reset. I just want to make sure, because that's a common one to use. Okay, and so for here, I didn't actually have a reset pin per se. I had enable and boot. Okay. Okay, so that looks okay. Cool. And there's this backlight control. I know that's going to be one of these. LED anode, LED cathode. I just don't know. I don't know which one it uses for that backlight control. That is tricky. Huh. I guess what I could do, because I have one of these modules here, I can probe it with a multimeter and find out which one it is. So I'm going to grab my multimeter off my desk and I'll be right back. It's all these fun challenges. You just never know what you're not going to know going into things like this. So, looking at here, okay. So the idea is, I should bring my lamp over here so I can see. So number 2 on here, and we're looking at backlight control, which is this far pin. So this should hopefully be relatively easy. Okay. Of course, it's not going to give it for either. How fascinating. I am not getting a continuity reading for any of them. So let me just double check, make sure I'm not taking correct. So I'm going to check ground. So ground should... Yeah, it's possible it's not even hooked up. I'm just going to check some other ones. So VCC is here. That should be on pin 4. Yeah. And maybe that's, you know, I know sometimes with these things they have like potentiometers you can attach to them. Maybe that's what it's looking for. Who knows? Okay, let me just check a couple more. Let's do CS. Chip select is on pin 8. Oh, of course it is. It's in the middle. I don't think it's hooked up. Do one more pass. I like them, so I'm just going down the entire strip. And I got nothing. So, I'm not going to hook it up. Do I leave a pad for it? Patch it in later? I'm going to say no. I'm going to roll the dice. So, if you think that's a dumb idea, put it in the comments. I am happy to accept. You can say that you were right all along when I finally figured that out. All right. Anyways, so let's go back over to our tutorial here. Okay. So now I think we have these properly labeled, and so yeah, 5 volt and ground. So he's using a 5 volt module. This one is not regulated for the 5 volts. It's 3 volts. Again, VCC is what we want to do. Ground is fine. Okay, that's an Arduino. Don't want that, but at some point he actually does this. This is DroneBot Workshop, coolest guy in the world. Okay. light to 3v3. What did he do for the Arduino? He had it to pin 9. I don't know, man. It kind of trips me out. Oh. Ha. I think I have a problem. Maybe I have a problem. Maybe I don't have a problem. So this one I've gotten to work. This one I haven't hooked up because I don't have anything to take except that cable. See, I see there's a little driver chip on that thing. I don't have a driver chip. This doesn't really have a driver chip. It just has a couple of small ICs in it. I'm sure it's fine. Yeah, whatever. We'll throw caution to the wind. We're doing a lot with this screen. This is a brand new thing. I've really not used it before. Okay, so GP23. Now we have to go see. Okay, so this is D in, and I have to go find GP23. Okay, so is that the same as IO23? Let's find out. So GP23, incidentally, is on pin 37. So if we come over here, GPIO 23, pin 37. So that sounds like a match. So let's connect that up. Okay. Next, clock is on GP18. So let me go grab my clock. GP18. Is that the same as IO18? Probably, but I like to check. IO18 is on pin 30, GPIO18. Looks like. So, clock. Okay, next pin. CS is on 22. That's our chip select. Is on 22. Ah, and there is our first issue. Tricky. Yeah. Okay. I know we're gonna double check, but I think that's gonna be an issue. So let's look. So that is 36. Yeah. So we may see if we can find alternative I2C. I know that is sometimes possible. Yeah. But we're just going to continue, but nothing's ever easy. Okay. Back to where we're here. Great. Okay. GP16 is DC. Alright, let's go find 16. Okay, so that looks to be there. So that's pin 27. Again, as always, just double check. 27, GPIO 16. Cool. Okay. Next. Okay. GP4 for reset. Okay, so GP4 for reset. Ooh, you come out a little bit. You come out a little bit. GP4 for reset. And looks like you are hiding right there. And that's pin number 26. Again, double check. 26, GPIO 4. Okay. What are we gonna do about this? And are you even allowed to like use SPI and I2C at the same time? Maybe. Never done it before. You can't. Probably should breadboard this out before I send it off, by the way, but who knows? Some of the things like Teensies have multiple I squared C options. The other question is the chip select configurable? Right? Because I think I think it can be. I don't think that's necessarily has to be a certain thing. Oh, let's explore. Let's see. So ESP32, I2C pins. The default. But you can configure your code to use other pins. Oh, that's lovely. Thank you, Random Nerd Tutorial. That's good. Okay. But you can, when using ESP32 with Arduino IDE, the I2C. So yeah, so the question is, how do we do that, and which ones are good? GPIO reference guide. And you can use a reference if you're using a bare custom. Yeah, which I am. 2 I2C interfaces. Tell me about them. Change default I2C pins. GPIO 33 and 32. So GPIO 33 and 32. 33. See, they're over on this side. Yes. Okay. So, let's see. So 33 is SDA. 33 is, again, I don't have to remember that I did that because that's not. You go away. And 32 has SCL. Lovely. Love it when applying comes together. Okay, so SCL, so that can go away, which means now I can slide CS into there. Okay, so I'm going to start making a list of all my references, because when I actually sit down to program this thing, I'm going to need to remember all of that. So, alternative I2C pin assignment. And I'm using 33 as SDA and 32 as SCL. Let's go ahead and save that. Ooh, hello people that are watching. Smartwatch. With us. I don't know how to see. Cool. Okay. Well, appreciate y'all watching. It's been an hour and we're just scratching the surface. So, okay. Wow, all of that just for trying to figure out what things I can attach my button to. Great. Okay. I'm going to go back to, I really liked their, this graphic here. This is nice. So, physical pin control, analog pin, DAC pin, pulse width modulated pin. I just got burned earlier today with just assuming that I knew what I could do and what I couldn't do. Port pin. What do they actually say about this? Anyways, all right, we're gonna look at ESP32 buttons and just go to where we've seen existing work. Okay, so GPIO 16 has been already claimed, so that's not gonna work. GPIO 15. I don't even see that on this. Oh, there's IO 15. Okay, so let's look at IO 15. Which pins on ESP32 can be used as digital input? How about Google? All ESP32 GPIOs can be used as inputs except GPIOs 6 to 11. Weirdly enough, the issue that I had today with some other board that I built was I used GPIO pins 6 through 11. Lovely. Yeah. I love reading this kind of information. Okay. So don't use any of those for digital inputs. So that means that I could use possibly some of these. So 25, 26, and 27. Let's double check. That's 10, 11, and 12. 10, 11, 12. Okay, so I do see that those have GPIOs of 25, 26, and 27. Okay. Let's try it. So B1, 25, 26, 27, and you are not B1, you're B2, and you are not B1, you're B3. And we'll actually connect you. Alright. Well, so that my buttons are hooked up. It's a very roundabout way of accomplishing that, but it is done nevertheless. Alright, what's next on the list? I think I have to teach students how to do this. This is fun. Okay. That's good. Okay. Accelerometer. Okay, do I get the screen? Screen's good. Battery monitoring. Let's do accelerometer first. Okay, so accelerometer. So I'm going to pull from the development board that I made a while ago, and this actually did work. I actually have it right here, and I wrote my own I2C code for the very first time. It was lovely. It took me like 14 hours to figure out. There we go. Okay, so here's my little accelerometer evaluation board. Again, we're going to make some changes to this, but we are going to just hopefully bring that over. Oh, are you for real? Why won't you let me just copy and paste it? I'm so very sad right now. It's fine. Build it from scratch. It's probably because I'm traveling across multiple easy EDA accounts, so I kind of get it. Okay, so let's start with just the chip. You there. Okay. There you are. I was very nervous when I soldered this thing. They're very tiny chips. Yeah, it actually worked, and I was very shocked. All right, we're going to go ahead and just label this guy up. So, hello. So you are SDA You are VGPIO. Okay, I ended up not using int1. I do need SCL. Ooh, common mistake. I like to drag those out just a little bit to make sure that they are properly connected. Okay, I do need my grounds. Did I really do that? Looks ugly, but whatevs. Alright. And VS. Yeah, sure. That looks like a thing that happens. Okay, you guys come out a little bit further there, please. Okay, so I don't need int, but all the other ones are built out. Cool. Okay. And I'm going to grab that guy over there and shove that guy over there. Alright, and then I need some 4.7K resistors. I like this one. And I need 2 of them. Okay, and so SDA is going to go to one of them, and the other side is going to go to the VCC. Ooh. Okay. And SCL is going to go to the other one of this. Lovely. I need a 1 microfarad capacitor. Please. I like this one, mostly because I have it in stock in the lab. Ooh. Oh, your horses, I don't need that many. Okay. I want to make sure I do this right. Okay, so this side is going to go to ground. This side is going to go to VDDIO. And this side is going to go to VCC. Cool. Okay. Then I need another one of those guys. I'm gonna configure it this way this time, though. Then I also need a 22K resistor. And and we'll do a ground connection there. We need VS over here. And we need VCC down here. And then I need to make that all look not stupid. It can be the hardest thing sometimes. Alright. I'm guessing this. Nice, okay. Thought it was gonna like drag the whole frame with it, and it didn't, which is great. You know, for such a tiny little sensor, that thing does sure take up a lot of room. You know what? Let's make this look better. I'm gonna drag you there, you there. Break you. Make you there. Break you. That seems nicer, doesn't it? And we can probably do the same thing for this one. Looks a little better, doesn't it? Okay. Alright, let's do some labeling. Yeah, let's do some moving of parts. Alright, so here is my ESP32. Yeah, all my buttons. Here is my accelerometer. Cool, thank you. And here is my screen. Which leaves just the right amount of space for a battery monitor module. Thought it was done for a hot second, but alas, I am not. Okay, so battery monitor. And for this, we're going to build a voltage divider, which is really just a fancy way of saying 2 resistors. Now, I've done this before. Done it the right way, though. Let's look. I'm going to look at version 2 of my smartwatch. Did have a voltage divider on it. I think it was for 5 volts, though. Voltage meter. So it used 100K and a 22K. Let's look at that. So ESP32 voltage monitor. I'm just going to say 100K just to see if that pops up. Yeah. We'll do that. I think that'll be fine. Okay. So let's actually go shopping for those. So I assume that those are surface mount components. We're going to find out in about 3 seconds. No, 0603. Great. So that is the right one. So we need you. Into 22K. We need you. And then we just have to hook these up and make them fancy. Okay. We gotta think this through because we want to make sure that we are probably fine. So I gotta be thoughtful about pulling the voltage off of the battery, feeding that into an analog pin and not making everything go boom boom. So we're gonna add this here, excuse you. We're gonna call this volts. And the question is do I attach that to the battery before we do the step down? I think we do. So we're gonna look at that. But first, let's go back to analog inputs. ESP32 analog inputs. Because I'd like to know which one of these I can use as an analog input. Linear, fine. Okay, so lots to choose from. Okay, well, let's look to see what's available. We're starting to fill up a little bit. All right. I see GPIO 34 and 35. Great. So let's use 34. It looks lonely. And then if I come over here, so I think it is BAT is what I'm going to use. Let's look at what's coming into my 3.3 volt. Yeah, it is BAT. Yeah, so you're getting BAT. One troop remove. Who is it? Is it you? Why? Man, you're just grumpy. Alright. I'm going to get rid of that for a hot second because it's just bugging me that these guys are just hanging out here. Make them a little bit nicer. As you make this, the easier it is to figure out what you did with your life later on. Okay. How are we going? Hour and 18 minutes, we already got our schematic done. And it probably isn't hot trash, maybe. Fingers crossed. Alright, now we get to figure out how to turn this into a printed circuit board that is that big. I don't know if you can tell. I need a banana for scale. Here's my finger. Ooh. Oh, better yet, actually, here's my wrist. So, yeah, it kind of looks big, but it's Apple Watch big. We confirm those assumptions. That's what we're looking for. Oh, look at that, 44 millimeter. I'm smaller than an Apple Watch, but probably once we add the the 3D printed enclosure on it, we'll probably be right at Apple Watch size. But cooler because we built it ourselves. So, yeah, I thought there was something that could. Okay, we'll just do this. Hello, people of the chat. Okay. I just turned that bag upside down on accident and dumped all these tiny little buttons all over the place. Can you tell that it's 2 in the morning? Okay. All right. All right. This is the scariest part of all. We are going to go to convert schematic to PCB. And this is, again, where things get bonkers because I've never done a 4-layer before, but I'm pretty sure I'm going to have to. So we're going to go 4 layers. 0, 0, 44, well, not 44, 40 and 40. Input width. Well, nobody cares about that. All right. All right, and because it's late, my screen is doing the whole like no blue light thing, but you really can't see the differences in all these colors, so I'm going to disable this. So like, I'm going to go from being very tan looking to very blue looking, just so I can actually see the colors. That is a lot of components to place. All right, so grid size 40, snap size 40. No, actually, I don't want to do that for this right now. I'm going to move all these components out of the way first. And what's very deceiving is the screen footprint is there, or the connector footprint is there, but the screen actually isn't there. So it's going to be bigger than that. So we have to fit all of that pretty much onto one side of the board that fits inside that little thing right there. So let's get to it. Delorted. Snap size 40. Let's go to our board outline. By the way, do you guys like my ambient spacey music? I added that, trying to make things a little bit less droll than my droning voice. Okay. Ooh. I hate this for so many reasons. Let's do grid size 10. No. Grid size 5? Yes, maybe. We'll see. Okay, because what I want to do is this is inspired by Apple Watch, and we don't do corners, we have rounded corners. So if I snap size 5, we'll see how we like this. Okay, maybe. Excuse me. Why are you the way that you are? Okay. Gotta do those last. Let's try that again. 5 mils, I should be on the right spacing. Yes, I do want to connect the nuts, okay. Excuse you. Good, okay, so now at least I know it's creating proper nets. Yeah, they've got a bug in their system where it's like every time you do this, you have to click off of something and then back on it. Look at them rounded corners. Are they rounded enough, though? Let's see, I was playing around earlier with some options. Oh, I made them even rounder last time around. Okay, let's do that. What would it look like? This would be like too round, right? Well, maybe that is the right roundness. Okay. So I'm thinking, yeah? Okay, yeah. So, come to there. because, you know, I'm already designing an incredibly small circuit. Why not chop off 20% of my available PCB space? It does look fancier, though. Okay. Gross. So, what are you, and how did you get here? Where are my components? Bat? What are you, what? Where did you come from? Alright. Well, good thing I checked that out. Oh, I really don't like that guy. That's gonna be so hard to hide, and it's so tall. So I have to like make space to like fold it over, maybe. Gross. Okay. Well, let's first of all, I'm gonna save this out. Okay, where are you, bat? Get out of here. We don't need you. How dare you, sir? Cool. Okay. Excuse me. Okay. So, it's kind of bugging me with the whole 3-volt converter thing. So we're gonna go see if there's an alternative version of this guy. And I would very much like to not have a giant thing. Oh, why are you the only way you are? Go on. Really? Ha ha ha. Yes. Smaller parts. Just have to go change everything. That's okay. Makes everything better. Oh, look how beautiful and small it is. Okay, so you, friend, go away. So just make sure battery is in, VCC is out, ground is ground. Okay. This is what's great to just be like a curmudgeon, because then you're like, well, it could be better, and then it becomes better. Okay, so VN, you, friend, are going to come over on this side. Wow. You're going to come over here. What do y'all think? Good decision to go to the the SOT23 package. So much small. Okay, so we'll go update PCB. Let's keep going. We want to apply the change. And look how tiny he is now. Glorious. Look how big everything else is. Oh, what am I doing? I want to go just look at that 3D one more time. Just to look at stuff. There we go. Yeah, now I know those guys look tall, but they do stick through the board. They should be relatively short, hopefully. We'll find out. They're so scary. Okay. Alright. Alright, so battery's going to kind of go on last because it's going to go on the back. I think the first thing we really need to think about is the screen is the screen is the screen, right? So it's got to go on the board at a very specific length because it's got a ribbon cable that wraps around. I can change this over to 1 millimeter now. I do need to double check that. Okay, so this is on the top. So this, when it wraps around, alright, so it's like here, wraps around, is one on the correct side. One is on the correct side. Okay. Always got to check that type of stuff. So I think I did some measuring earlier, and I think that's about where it goes. Okay. So some additional considerations I want to make. So I want that to just stick slightly off the edge. I'm going to make some controversial calls here, by the way. I'm going to delete a lot of these labels because they're just going to get in the way and make everything kind of confusing. Now, also, I'm going to go over here and I'm going to turn off ground. Oh my gosh, look at all those traces. And VCC. Alright, only got like a billion traces to make. Okay. Alright, next considerations. You know, always think about the physical considerations. These guys need to get mounted on the side. Unlike Apple Watch, I will not, unfortunately, have a touch screen. Sneak those guys up even a little bit closer. Okay, let's go find their resistor, friends. So according to this, their resistors are 7, 8, and 9. Resistors 7, 8, and 9, please report to the principal's office. Opa. Opa. There's a really tricky decision. Do I keep the labels or not? We'll keep them from now, but we'll ditch them the instant they start taking up too much space on my board. Notice how like every time I like do something, I save it. With this browser-based software, man, you never know when something's going to like explode on you. Okay, ESP32. That's the kind of the elephant in the room. So I'm going to position with the antenna to the outside, as close as I can, and try to actually that looks centered. This thing's going to be like via central. Okay. And in terms of the programming buttons, I'm going to kind of reserve the corners up here for all of the voltage stuff, which means I think programming buttons are going to come down here. Okay. So this one is the boot. Oh, God. It switches all over the place. This one is the enable. Make sure things are spaced out evenly. Cool. This enable has a resistor. Resistor 6, it looks like. Let's come sneak this guy in here. Okay. Alright, let's start talking. So we got those taken care of. Accelerometer needs to do a thing. Okay. So let's focus on. Let's grab the accelerometer. Where's my accelerometer friend at? Here's my accelerometer friend. So you are friends with that person, that person, that person, and that person. Who else are you friends with? So C6 and 7, and 3 resistors. So I've got, excuse me. Oh, okay, yeah. 3 resistors. C6 and 7. Losing my mind. C6. Okay. Yeah, because that's just going there. Okay. I think you are going to hang out up there. I think our voltage or battery monitor is going to hang out with him too. So our 13 and 14. Easy there, Tiger. Gonna hang out there. And then, yeah, charging this side of the board? Because of course it is. YouTube. Corruption. Zone. Okay. Cool. Man, this is tight. I'm going to start with the big stuff first, just to see what kind of a mess I've made for myself. So U1 is surrounded bar. R3, R1, and R2. And again, we might. So these guys are kind of extra. These are the charging status LEDs. I'm gonna kind of do those last because if there's not room for them, they can just go buzz off. All right, so that's gonna go away. These all have unique footprints, so I'm really not gonna worry about labels with them. Same with that guy. Same with that guy. Okay. Let's see. So we go from U1. Yeah, I think kind of cascades down this way. So Q1 doesn't actually have any friends, so that's good. So I'm going to actually shove you down here. You have lots of friends, so you've got R4 and 5 and C2. R4, R5, and C2. I like to hang out with these guys. This is just where labels are really going to start to become a pain in my side. I would really just like to ditch all those, start stacking stuff in here. Hello, you kind of belong there. When I click on it, it still tells me which one it is, right? That's fine. don't be mad, people. I am ditching labels.
Forgot about 3.3 volt conversion. So let's go back up here. So that's got just a one. So that's got R3 with it. Where's R3 at? There's R3. LED 1 is charge and LED 2 is standby? Yes, okay. So we're going to try this. Don't have to like it. Okay. Capacitors that need friends. So C1 is just straight up power ground. That's fine. You can come out. Ooh, you're so big. Okay, so let's get you there. Okay. C5. Where are you, friend? C5. Does anyone see 5? Oh, there you are. Okay, so that's down by 3.3 volt, friend. Okay, so let me just make sure. So C5, C4. You guys hang out with this dude. C3. Is he going to be there? Is that correct? Where's C3? Oh, and again, it's just a, yeah, hanging out between Vin and ground. Okay. Make sure these are all kind of facing in a way that maybe possibly makes sense. these guys down in this remaining space. That's going to be a stretch. We will try our best. Oh my gosh. That is ugly, but maybe fun. Yeah, this other side's going to be cake by comparison. Okay. That's going to go to the bottom layer. Wow.
how tall are those buttons? Let's look, because if they're tall, we might put them on the other side. We will see. So let's see. .5 millimeters tall. What does that compare to our module? A little bit taller. Oh, that's not the right thing I'm looking at, though. No, it is, yeah, 3.5 mil. That's ESP32. Let's look at that. I want it to kind of be away from the screen so we can kind of bezel it, so I'm going to leave it on that side that it's at. Okay. Well, that is... that is a beast. And so now the question becomes is how do you route all of this? And I think the answer is with copious amounts of vias. This is just going to be a big old massive, just all vias all the time. Alright, so we're going to connect what we can. And then we will start doing what needs to get done. So let's go to 2.1. small changes to hopefully make this go together a little bit easier. Until things get serious because they get quiet. One of the fun challenges of this type of design, though, is all the little decisions and compromises that you got to make along the way. It always felt weird for me. There's got to be a better way to do that, right? I think the goal is just get as many of these guys hooked up as we possibly can, so that we don't have to run billions and billions of vias. Okay. I don't know if I see any that are just super obvious connections that are going to be easy to make. Let's try that. Yeah, because I'm just trying to cut down the total number of views that I gotta make for this. Yeah, at the same time, you don't want to make like really dumb traces just for the sake of making dumb traces. So I'm trying to be judicious. also trying to reduce the number of traces that we run underneath the antenna. I know that can be problematic sometimes. So we will try to avoid that if we can. Let's see how we're doing. Yeah, look at that. We're not in terrible shape. So we got some work to do. That needs to go to that. And I just want to make sure that it would be dumb, in fact, to like try to go through there. Yeah, we'll take it on the other side. Okay. I don't see any other kind of obvious paths to take, so let's start taking things down. So, use video. Easy there, Tiger. Does not like that. Okay, I'm gonna have to get super close. Put one R2 right there. They're going to be RX. Just out of curiosity. Definitely that's right. And we are going to have to be careful about running over that. We drop those. Let's take care of B2. I think maybe I'm gonna like power plane the bottom as a battery plane. That could could take care of all these little battery connections, maybe. We'll explore that. Boy, you know what? I don't really like. To be taken care of. And for B1, do a little rerouting here. Bring you down here. Like that. Over here. Drop B1 via there. Come down on this side. Drop B2, B1 there. Okay. Okay, now I got standby and charge that needs some attention. We'll have to wrap them around, but I think that's okay. Let's see how that looks on the back side. Yeah, again, that's going to look a little bit weird there. Okay, let's try this option. And I know that's not ideal. That's okay. We'll make it by. Like I said, I think we're going to do that as just a big plane down here. So let's come up here and let's take a look at those connections. So let's do here. That should complete the connection once we're done. You, my friend, there. All the other battery connections are there. Okay, I think this will work. So we're going to come down here. We're going to set snap size to 5. Here, we're going to choose bat. Come here, here, here. Look at that, all the battery connections are made. Now, we are going to have to rebuild that after we drop more vias. We should be okay. So let's look at ground. Or VCC. VCC is okay. Let's do VCC. So, I'm going to turn off copper zone for now. Let's look at vias. Actually, you know, VCC, VCC. You can see it's kind of getting grumpy about me placing these because it's eating into the layer down below. But ultimately, as long as I avoid those, we'll be okay. Just want to make sure everything gets a fair shake. Okay, so what we'll do is we'll come down here. We will rebuild copper area. Make sure we didn't cause any more issues. And now we can come to inner 1. Set our snap size to 5. Here. Just like we did before. Let's go to PCC. missed one. That's okay, we can fix. Excellent. Now we are just down to the grounds. Let's look at all of those. Hoo-wee. So many to connect. Yeah, it might have been a little bit more sensible to route these another way, but this is where we're at. Okay. Look at just reducing the overall number of connect vias we got to drop. Let's see if we can get some more. Alright, so now what we're going to do is we're going to kind of go around and just kind of locally drop down some vias to try to get all these guys connected up. So now those should be okay. Let's drop one here. Just going to kind of try to make my way around logically. Those two are okay now. That's okay now. Should be okay now. This guy needs a friend. some help. Okay. Whoo-wee. Well, we probably missed a couple, but we're gonna see. All right, so first thing we're gonna do is we're gonna go to bottom layer, and we're gonna rebuild copper area. Okay. We're gonna turn off bottom layer, we're gonna go to inner layer here, and we're gonna rebuild copper area, and that's just gonna build around all these new vias that we put in. And then we're going to come to inner 2, and we're going to see if we can make a ground layer. Set snap size to 5. Okay, it does appear that we missed some. Where did we miss them? Aha. Sneaky, sneaky. Right there. Is there any way to get him out of there? No. Okay, so. Via for good measure. Rebuild a bunch of copper areas. Okay, so rebuild bottom. Turn you off. Inner 1. Rebuild you. Inner 2. Rebuild you. Save. DRC errors. The magnifique. Alright, so let's go to bottom silk layer. Let's give this thing a name. Which V 3.0. And Rainbow PCB. That's me. Whew, that was quite a build. We've been going for almost 3 hours. Wow. But what a piece of work that is. Like I said, battery will go there. And the screen's going to overlay on top of it. That is a lot of work. Now we just have to hope that it actually all works. And my favorite part is seeing, does it actually manufacture? $2. That is not bad. Okay, well I think I'm going to stop there. I will make this board file available and the recording will be on YouTube, so thanks for those who did hang out for a little bit. Ooh, hi, Right Night Studio TRNC. I'm making a smartwatch that is ESP32 enabled. And so I can actually kind of show you around a little bit. So lots of different components here. So first thing is we've got to power it, right? So we've got a lithium-ion CR2032 battery. And so it's a little coin cell battery. I got one right here. And they are properly rechargeable. Yeah, they supply 4.2 volts. And so I've got a charging circuit here that will let you charge it up via USB. And then to help with that, I've got a overcharge and over discharge protection circuit, so you can't blow the thing up. I've also got 2 LEDs that'll go on board, one that says when it's charging and then one that says that it's been topped off in full. And then you've got to step that voltage down to 3.3 volts. And so I've got a step down circuit right here. And then it's all powered by ESP32. So you get Wi-Fi and Bluetooth on it, so you can get notifications from your phone. You can connect it to the internet, do all sorts of fun things. To program it, you've got to have a enable button and a boot button. And then I've got 3 buttons, so when you program it, you have to like hit these guys to actually get it to accept the code. And I've got these 3 buttons that'll be for just controlling various functions on it. And then I've got an accelerometer that I just started experimenting with. So you can't, it's hard to find the raw accelerometer module. So I found one that is not very popular, but it's plentiful. I built a little evaluation board for it so that you can kind of make it a Fitbit type thing to kind of track your movements. And so we've got the circuit right there. And then for the screen is really cool for this thing. So it is this like high power LCD screen that is circular. And what's really cool about these things is I've seen a lot of like really fun watch faces done for them. I'm pulling this and I use like tons of resources from other people. But yeah, like these are the screens for them. So really, high density, really bright color. So I'm excited about all of that. And then I've got a little battery monitor circuit, so you can actually kind of track how much battery is left on it. And then yeah, here's the little screen circuit. And so yeah, I've been going at this for almost 3 hours. Built all this from scratch using these 400,000 tabs here. And the overall goal, so this is, it's kind of hard to get a sense of scale, so this is 40 millimeters by 40 millimeters. which is actually a little bit smaller than the Apple Watch. And so probably obviously not as powerful as the Apple Watch, and I got to program it all by myself. But yeah, so this will be on one side, and then this this screen is going to be wherever it went. The screen that I was showing you is going to be yeah, on oh, here it is. There we go. So that screen's going to be on the back side there. So yeah, so it'll just solder on. It's got this little wraparound ribbon cable that will loop around and then solder right onto those pins. So I'm super excited about it. It's the kind of most complicated circuit that I have ever designed. I've designed a lot of circuits. And so on my little easy EDA thing, I think I've got, yeah, I've designed 540. But this one's kind of special because just the sheer number of components to make it work. And also I had to design it as a 4-layer board, which means I can just run all these additional kind of contact points. I don't know if it would have been possible to do it as a 2-layer. I usually design 2-layer boards, but yeah, it's been a heck of a night. So I started around midnight and it is now 3 in the morning. So, you got any questions or so? I'm excited that someone popped in to watch this. I had maybe 2 people here earlier watching me do things, but for me this is just relaxing to do, and I figured I'd share it with other people. But I do open source all my stuff, so I'll post as soon as this is done recording. I post it to my YouTube channel, which is Rainbow PCB, for anyone who wants to follow along, make their own. And then I also just include links to where people can just download the files and get them made themselves if they want to. It's super easy. I use a service called JLC PCB. There are these guys, and you can literally get 5 boards made for $2. Have I ever made a slime VR tracker? I have no idea what that is. What is a slime VR tracker? Slime VR tracker. Apparently it's a thing. Full body tracker. OpenSet facilitates full body tracking. Oh, interesting. So I have done stuff that does body tracking, but not like this. So interesting. Yeah, so I've used a lot of like Xbox Connect does really well with doing like body tracking. So I've built a lot of applications for this, for that. But what is this like meant to be used with like an Oculus Rift or something like that? Oh, legit. Okay. So it looks like they're using, these are probably infrared emitters if I had to guess. That's really cool. I wonder what it's using for sensors, because like these are probably, if I had to guess, emitting something, but maybe they work on their own. Oh, that's hilarious. Tracking. Oh, so they use IMUs. Okay, no. Yeah, so open source. Yeah, so it's using, so IMUs this, yeah, inertial measurement unit. So that's accelerometer, gyroscope, so same kind of thing that is that little chip that I'm using in mine. So like, probably a different chip, but same idea as this, yeah, this little accelerometer unit. I wonder how accurate that is. It looks really cool. So 5 trackers, lower body movement. Okay. 100 Hertz refresh. Wireless. I wonder what it, oh yeah, look at that. They got a little lithium polymer battery on the back. There's the ESP32. Wow. Yeah, on-off switch. Mine doesn't have an on-off switch. I'm going to use a sleep function, so kind of just use relatively low power because I don't want to have to like turn your watch off and on. But with these, it makes sense because you want to turn them off when you're not using them. Look at how cool that is. You said it's open source, so I wonder if they have the. the PCB somewhere. You can build it. Available tracker sets. Okay. Ooh, full body set. Open source electronics. Good for them. Oh yeah, they're using Grove, so you can always tell Grove because they've got these like cool purple PCBs. You get the firmware and the software, and oh, so it's with Steam VR. That's cool. I have not done a lot of stuff with Steam VR. How cool is that? Cool. So, do you design circuits? Do you just interested in electronics and technology? What's your experience? Price-wise, that's pretty good. Oh, it's on Crowd Supply. Crowd Supply is really cool. I want to start putting my stuff on Crowd Supply so that, again, like people can just, if they want to just buy it, they can just buy it already made. But also, like this person's doing, just make them open source, so if people want to kind of build their own or customize it, that's cool. Yeah, I really dig the whole open source thing. That's, I mean, that's how I learned all my stuff. It's just from other people sharing what they've made. VTubing. Yeah. That is super cool. Oh, yeah, there's Connect to VR. Yeah, so I've done Connect stuff before. And it's okay. It's stupid easy to write code for the Connect stuff. And what's nice is the Connect modules are so cheap now because like nobody uses them anymore, so you can get them crazy cheap. I just bought 2 a couple weeks ago. Let's see, made 2 obstacle avoidance robots with some kids. One of them can grab objects and move them out of the way. That's pretty sweet. So I wonder what kind of gripper are you using? Is something like actuated with servos? So done through a school or a after-school program that you work with. So I teach college students. So I run a program called Creative Technologies where we build really interesting electronics and do a lot of Arduino stuff and 3D printing, laser cutting, all sorts of really fun things. So this is it's summer right now, obviously, but this is a project that I'm preparing for a class that I teach called Advanced Interactive Product Design. So my students are going to be designing their own smartwatches and programming them from scratch and doing 3D printing for the enclosures and wearable tech. So yeah, so they'll build these and program them. But I always like to make sure I know what I'm getting them into. So I'm building my own. Like I said, I don't know if you were here earlier, but this is my 3rd smartwatch that I've designed, and this one's way better than the previous 2. But yeah, so hopefully, like, I'm trying to figure out if this is going to be too tricky. This is going to be like the final project. Raspberry Pi Arduino was part of a university course. Okay, that's good. Like, yeah, so it's, yeah, because there's like more and more like colleges that are kind of getting into this a little bit. We're kind of one of the first that has like a whole like 4-year degree all about kind of this inventing technology stuff. It's a little bit different than engineering because we kind of combine elements of like engineering, industrial design, computer science, and entrepreneurship. So my students kind of go through this whole process of like inventing stuff and then figuring out how to actually build businesses out of it. But yeah, resin printers. So so we've got a couple different printers. We've got lots of the Ender 3s. I think we're now up to like 20 of them. So we just mostly strictly print filament with that. But last year, I plunked down and got 3 of the Elegoo Mars resin printers for the lab. So let me pull them up real quick. So, and I actually got the 3 different versions of them. So Elegoo, Mars, and when I got one, was like not super convinced that I'd made a good decision. So my students were like, "Hey, we got to get like a resin printer. They're so cool. They're so detailed." And I bought just the printer. I got it on sale for like $200, and it was like messy and gross. And I was like, "This is the worst." And then one of my lab assistants that was working for me over the summer, big 3D printing guy, he's like, "Well, we need to get the wash and cure thing that goes with it." And so yeah, so it's like this yellow one. And so I bought that, and it showed up 2 days later, and it completely changed my mind. Like, it is so easy now, and it's not messy, and it doesn't smell, and it is really cool. So like anytime I like talk to people like resin printing, it's so cool. But you got to get the wash and cure station with it, otherwise like you're gonna be miserable. Because I was like just having like these like little plastic boxes with like alcohol and toothbrushes and stuff, and I was just like, no. But when I got that, I was like, oh, this makes sense. And then I ended up buying 3 for the lab, and we use them in this advanced prototyping class. The thing that I have to be careful about, so I did as part of the class, one of the other projects the students make is we use Fusion 360 to do an ergonomic hand study of their own hands. And they have to design a computer mouse that is custom fit for their hand. And so that teaches them about ergonomics and how to do form and function. And this year I had them 3D print them on the resin printers. And just like really good detail. In past years I had them do them on the filament printers, but they have to do a lot of like surface sanding and polishing and painting and stuff. Whereas on the resin printers, they just come out so smooth and perfect. The downside, and this I hadn't tested it well enough, the downside is that the resin prints can be brittle. They're very strong, but like they don't flex. If you flex them, they will crack and break. Or if like I had a student like drop one and it just like shattered. And so that's if you just use the regular just resin that you can buy. You can buy flexible resins, and so I think if I do that assignment again, I will have them use the resin printers because again they're just so good. But I'll have to experiment with some of the flexible resins because like when they're clicking on the mouse buttons, too many of my students literally just like shattered the mice, pushing on them. So I'll have to experiment with new resins to make sure that works. But they're great. Like I said, I was a huge skeptic, but Amazon was just having a sale, and I was like, well, this is just too cheap not to buy one. And they are awesome. And a lot of students will use them for various projects, in addition to just the PLA printers that we've got. But the accuracy and the detail is just insane. They are a smaller print size, so like you can't print super huge things on at least these ones. But the detail, like I said, is unrivaled. So yeah, definitely worth checking out. I would just like, if you're interested in one, I would just make a point to like check Amazon every couple of days because they always go on sale. Like I said, when I got the washing here, it was like $50. So my first set I got was like a total of like $250. So I wouldn't like get in a hurry to like plunk down like $350 on them. I'd just wait for a sale because they go on sale all the time. But yeah, no, it's yeah, it's good stuff. So yeah, like running the lab, like running this program. So started doing these streams just to record them and kind of, like I said, see if people were interested in how technology gets built. So yeah, but you got any other questions? I'm happy to answer. So otherwise, as they say, like and subscribe. Check out the YouTube channel. Have a Discord server that's separate. So my lab has a Discord server that we've set up, and we've got about 300 people on that. But I've got a lab just for this, or a Discord setup just for this, but literally just started this thing like 3 days ago, so nobody's on it yet. But yeah, always interested in getting feedback from people that are interested in technology. Yeah. Complete it. Just got pinned on the Discord server. Oh, he joined. Awesome. Oh, the other thing I didn't mention that I do on this channel is I've got a big, a DJ setup, and yeah, if I'm not making PCBs, I'm making music with some of my students. Let's see if I've got a good example of this. No, maybe it's an open lab. Yeah. So this is the. So I'll live stream that stuff sometimes too. So, there we go. Yeah. So this is the setup that me and a few of my students are working on just to make some jams. Nice. So you do music production as well. So it's been interesting. So I like techno and electronica and EDM and stuff like that. My two students that are also interested in it, they're making other kinds of music, but yeah, we have various musical tastes, and not everyone likes the kind of same music that I do. But what kind of music do you like to make? Because I mostly just tinker around on it. Yeah, so what kicked this off was I've got my very first piece of like real music equipment was this guy. It was a Roland SP808, so it's a sampler that you can kind of do some basic work on. And I had that for a long time. Oh yeah, I started the Discord like 2-3 days ago, so I'm not surprised that you're the only one on it. But hopefully, more people will join soon. Like I said, just started streaming 4 days ago. But yeah, oh, actually, one interesting thing you can kind of see in the back here. And I'll be doing one of these boards a little bit later this summer. So this thing, kind of in the center right here, it's called a MIDI mixer. It's a custom PCB that I design and build that allows you to mix music using MIDI signals. So it like lights up. It's got buttons and knobs and sliders. And so I'm making a new version this summer that has DMX controls in it for being able to control lighting as well. And it's, again, like for one of the classes that I teach, all my students have to make their own. And then in order to prove that it works, we actually throw a rave where we invite like the entire like university to come out and they perform, they mix all their beats and their songs, and yeah, we just have like a big old rave, and it's actually like they get class credit for doing it. I made the mistake last semester of telling them that I would give them extra credit for like every single like person that they could get to like come to the rave, and we ended up jam packing the entire lab full of people. And I have like lasers and smoke machines, and you can see some of my little like chaser lights and stuff. And it ended up meaning that on their final grade for their class, they got like over a letter grade bump, and like a third of my class had more than 100% in the class, despite the fact that it's like one of the most challenging classes that I teach. But just they literally had so many people show up, and it was cool. So yeah, so one of the things they do is they build their own little mixer. Like I said, and I'll announce it on the Discord server when I'm going to be doing that one. The nice thing about the Discord is I can kind of give people a heads up when I'm going to be streaming, because I don't have a regular streaming schedule. I just a couple times a week. But yeah, I'll send out an announcement when I'm going to do the MIDI mixer, because that's a really fun one. If people like making electronics and they like making music, it's cool to kind of make your own kind of DJ equipment. So, but yeah, so Roland was my first one. A couple of different audio boards. I just got the Pioneer DJ mixer. I'd been looking for one for a really long time, and I found that at a secondhand shop, and yeah, built out this entire giant cart that's got speakers mounted to it. The whole thing is on caster wheels, so you can move the whole thing around, so the party goes wherever you want to go. And then added dual monitors. Haven't really decided. I've got it running off of a Mac Mini right now. I've got a big PC tower that I can run it off of that I think is a little bit more powerful, but I just have to migrate all of my software and music onto a PC. And it's set up to kind of, you can perform side by side with another person if you want. So there's like 2 sets of headphones and lots of things to do. So just getting started with it. Like I said, we'll be streaming some music. I've got 2 guest streamers that are going to stream music with me next week, so be on the lookout for that. But yeah, I think I'm going to call it a night. So super nice to meet you, Right Night Studio, TRNC, Person of Doom. So, and yeah, catch up more on the Discord server later on. And yeah, glad people could join for the evening. I will catch you guys all later.